All right, so continuing our discussion about basic set concepts, I've mentioned from the previous video that this particular chapter will be much more about vocab words and symbols. Okay, so it is important for you to understand what the word is and also what the symbols would mean. So these are the first symbols that we will be encountering. So, what makes up the membership of a set? So, the notation, okay, this notation, the one that looks like an E, okay, so it's like a C and then with horizontal line like that. So if you see this symbol, it just says is an element of, okay? So it's like this element, is it really whatever this element is or this item is an element of whatever is in this set, okay? Now you will notice that every time we cancel, okay, close quotation, we cancel the symbol that is simply saying it is not, okay? So if you see this symbol, you are talking about this item if it is found inside the set. So let's have some examples, okay? R is an element of the set A, B, C, dot, 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 Z, okay? Now you will notice that that we have these three dots here, which we call as the ellipsis, meaning by common knowledge, we know what is next to the letter C here. C, D, E, until we reach the last element, which is Z. So if you're going to take a look, this set is what? By describing it, it looks like this is the set of the alphabet. And is R an element of this set? Definitely, R is part of the alphabet, so this is true, okay? Even though you do not literally see R listed down here, the fact that you have an ellipsis here, meaning it's common knowledge, looking at the pattern here, we know what are the missing elements here up to the last entry or the last element of that set, okay? Next example, 7 is not an element of the set that contains 1, 2, 3, 4, 5. Okay? Very simple. Do you see 7 in this set? No. So again, this is a true statement, okay? Because 7 is not an element. Now let's take this example next. We have the set A is an element of the set A, B. Okay? Now again, symbols, notations are very important. This is false, okay? Why is this false? This is a set. How do we know it's a set? Because you have your braces here, all right? So a set cannot be an element of another set. So that is very important to remember, all right? So remember, if it was written as A is an element of AB, then this is true. But as you can see, the presence of the braces makes this statement false. All right. So we have encountered some natural numbers earlier. So when we talk about the natural numbers, these are your counting numbers. Okay? So when you are counting, what number do you start with? You start with the number 1. Okay? So those are your set of natural numbers. Now, the 3 dots, which we call as ellipses, you can find your ellipses in two places. Okay? They could be found between, okay? Just like the example earlier, A, B, C, ellipsis, and then Z, okay? It just means that this, whatever is the missing, whatever next elements are, it's common knowledge based on the pattern that we see here. Or we can see it before or after, okay? So, like for example, here you have 1, 2, 3, 4 ellipses, okay? It means that we know that this is not going to end. It's going to continue for a long, long time. It's going to be a long list of elements. Sometimes, so if, for example, if we're talking about integers, okay, It could be this, this, this. You have your ellipsis. Let's say -2, -1, 0, 1, 2, and then ellipsis again. Pretty much it's going to extend on both sides. All right? So that is an important thing that you have to remember about your natural numbers and ellipses, by the way. Okay. So let's have these. Express the following sets in roster method. Again, roster method is the most usual. So we have set A is the set of natural numbers less than 5. Okay? That is important, less than 5. So if we list them down, we have a set of, all right, our braces, numbers, natural numbers less than 5. So again, we start with the counting number 1. So 1, 2, 3, 4. Now, do we include the number 5? In this case, we do not, okay? Because of this description. It has to be less than 5. All right? Now, let's have this next example. We have set B is the set of natural numbers greater than or equal to 25. Okay? So we now have our set B. It now is greater than or equal to 25. So the question is, are we going to include 25? Yes. Okay? Why is that? Because of this part of the inequality. Because you have the equal to, it means 25 is going to be included. Here, we do not have the equal to. That's why it is not included here. So we have 25, 26, 27, and you can already use your ellipsis because this list is not going to end. All right? So you can represent your set B just like this one. All right. Excuse me. We have the set E. This is now in set builder notation. Set E is the set of all elements X in such a way that X is an element of the natural number and X is even. Okay? So that is the description. It has to be even. So we're talking about natural numbers. Do we include 0 in this list? No. Okay? 0, we do not count including 0. So the first even number to be listed down will be 2, followed by 4, 6, 8, 10, and you know the pattern, so we can use our ellipsis once again. Okay? So the following slide, the next slide will show us different ways of how set builder notation could be represented. So remember when we talked about set builder notation, right after the vertical line, okay, right after the vertical line is a condition. So it does not have to be phrases or sentences. Sometimes your condition would look like inequalities like this. So this is a description. It means that it is a natural number and it has to be less than 4. Okay? Now, one thing that you have to be very careful when it comes to inequalities is that we have the regular less thans and regular greater than, and then you have the equal tos. Okay? So remember, if you have the equal to, the given number will be included in your roster, in your set. Okay? So here, you can see that we have some compound inequalities. If you take a look here, this is just a 1 inequality. Now here, we have your compound inequality. So it's like 2 inequalities written as 1. So how are you going to read this? So if you get this part, okay, you can rewrite that part as X. The pointy end is at A, so X is greater than A, okay? And then if you take a look at this next part here, X is less than B. So if you're going to read it, it is the set of natural numbers that are greater than 4, but less than 8, okay? Now, remember, we do not have any equal to symbols, and so we do not include 4 and 8 in this example, all right? Here, let's jump onto this part. So as you can see, you have the equal to on this side. So it means the 4 is going to be included on your set, okay? And if it is the one on the other side, 8 has the equal to sign, then 8 will be included. If both of them have equal to, then both of them will be included in the set. All right? So let's take a look at this one. express the following using using the roster method. So we have the elements x such that x is a natural number and x is less than or equal to 100. Okay, so our set will include, now remember, the order does not matter. So since it was mentioned here that x is less than or less than or equal to 100, 100 will be included because of the equal to. So we can start with 100, followed by, it has to be less than, so we know it's 99, 98, okay? You can already use your ellipsis, comma, you can list down the last element or the last two elements, so you can have 2 and then 1, and then close the set, okay? The next example here, we have all the elements x in such a way that x is a natural number, and it is between 70 and 100, okay? So if we list this down, we know that we have numbers that are between 70 and 100. Now, looking at our inequality, there is an equal to symbol right beside 70, so it means 70 is going to be included. So we have 70, 71, 72. Now, this is going to be a long list, even though it's up to 100. So you can use your ellipsis again. We have 98, 99. Do we include 100 in this set? No, because there's no equal to sign here. So we close our set. Okay? So that is very important when you are reading the set builder notation.